Everyone, am I audible? Yes. Harshit,
Good morning, sir.
good morning. Welcome to the class. So, just observe today how to move, how to behave in the class, everything. Right? Today is your first class. Okay. So, in the last class, I discussed with you about activities, introduction of the chemical equations given. Then activities also explained. Just I'll remind you about that activities again. Here in the activity one, we are observing the reaction between the calcium oxide with the water. For that, I required some materials. What they are here? Calcium oxide, that also called as quicklime. Remember that chemical names or general names in our daily life, what we can use, right? Here, quicklime, it is chemically calcium oxide. Water is required, beaker or test tube required, right? To test different characteristic properties of the substances, we required a few more materials also, but we won't go for all the characteristics. I need to observe only its acidic basic nature. So for that, I require litmus papers, right? Then how to complete the procedure? First of all, you are taking a beaker, adding quicklime or water to that first, then adding the another substance. Suppose if the beaker is filled by water, then what to do? Just before adding calcium oxide into the beaker, you need to touch the beaker to know about the heat energy of the content. Then add a quicklime. Then again touch the beaker after adding the quicklime into the water or water into the quicklime, anything. So here, by adding quicklime into the water, you will get a solution, right? You will get a solution. That solution is here called as slacker lime, calcium hydroxide. The liquid solution you will get by the calcium oxide and water is slacker lime, calcium hydroxide. Then here, what we noticed, here we will notice that heat changes, that contents becomes warm. Then one more you need to notice, we have litmus papers. So before, does that water has any nature? No nature to the water. Then after adding calcium oxide, something is happened between water and calcium oxide. Then here they together given you a liquid solution called as slacker lime or calcium hydroxide, right? Then use any colored litmus paper. It may be blue or red. Suppose if you use blue litmus paper, drop that into the liquid solution. Then observe, does it change its color or not? Here what we'll notice, blue litmus remains blue. Then dropping red litmus into that. That red litmus changes into blue in color. Red changes into blue. So here, this will indicate you the nature is changed to basic. The nature is changed to basic. So these are the observations we made in this activity. So quicklime reacts with the water to form slacker lime and releasing energy, heat energy. And also we will notice that litmus paper color, blue litmus paper color remains as blue only. Red litmus paper color turns into blue color. So the nature adopted by the slacker lime is basic, right? So here in this, what the result we are able to give? A reaction, some completely different characteristic properties substance produced, right? Here what the result we can write here, observed a new substance is formed. Along with that, we noticed that becomes hot, heat energy liberated. Then one more we noticed, blue litmus changed into red, or red litmus changed into blue? Red litmus changed into blue, right? So red litmus changes to blue. So these are the observations in your activity 1. Then activity 2 is given here. What is activity 2? The reaction between sodium sulfate and the barium chloride. Right? For this, what we required? 2 beakers, water, and 2 salts. What they are here? Sodium sulfate and barium chloride. Water, beakers, right? Or test tubes. Then any other required material? Nothing. Just we are observing. In the activity 1, I need not to test always what happens, right? For different characteristic properties, I am considering the different reactions, right? In the first one, already I know that what heat liberated and the characteristic nature, the nature of the substances changed. So here I need not to check. Nature compulsory changes. Sometimes heat may be liberate or absorbs. Then I am taken one new reaction, that is Na2SO4 BaCl2. Then I need to prepare these solutions because they are solids. So here adding that Na2SO4 some quantity into the 100 ml of water in taking a beaker, right? So then 100 ml of water in another beaker added by BaCl2 salt. Then you will get 2 liquid solutions of Na2SO4 and BaCl2 in different beakers. Then add one of the solution into one of the beaker. Then what do you notice here? By adding one of the solution in another, that white color material is formed and it is reaching the bottom of the solution, and it will be separated as a substance, white colored undissolved material here. White colored undissolved material. So what that white colored undissolved material is here? That which is prepared or given by 2 liquid solutions here. 2 liquid solutions. So that is here simply precipitate. Undissolved material given by the 2 liquid solutions reaction is called precipitate. It remains at the bottom of liquid solution. So what the liquid solution is? What the solid material is? So solid material we can call it as precipitate, right? Liquid solution is aqueous solution of particular salt here that produced in the reaction. So what the result we can write here? In this reaction, precipitate is formed. Substance remain undissolved at the bottom of liquid, right? So this is the observation you made in the activity 2. Then activity 3 here. What is activity 3? Observing the reaction between simply a metal and the acid. A metal and the acid. So here for that you required a metal. It may be zinc or maybe any other metal. Then one acid HCl is taken. So reaction between the zinc and the hydrochloric acid. To observe these, I required a few materials. What they are here? Zinc or magnesium metal granules. Along with that, one acid is required for that contents. To take them, we required a dropper, glass tubes or beaker, etc. So you can make them right in your list. Then I need to observe if there is any gas liberated. That gas nature also I need to decide. So how to decide that gas nature? Using the matchstick, burning matchstick, right? We have few observations with the burning matchstick, right? So I'll show you that. In the procedure, what we'll do? Taking the liquid, that is hydrochloric acid, in a test tube or in the conical flask, right? After that, drop 1 or 2 granules of zinc or the magnesium, right? So here they can react. How do we notice that reaction between them? See here, in this I have taken a liquid, that is HCl, in a test tube, and I dropped 1 zinc metal piece. Here you are observing that bubbles formation on the zinc metal piece, right? When we drop zinc metal piece in that, I observed that bubbles formation on the metal surface. That is indicating me the reaction is taking place between the acid and the metal. So this is your observation. Why the bubbles are formed here? Why they are coming to the surface of liquid? So here in a liquid, bubbles presence or presence of bubbles in the liquid will indicate you presence of gas or liberation of gas. So by the reaction of zinc metal piece with the acid, indicating you gas liberation. Or you can take magnesium also into that. HCl added by the magnesium. See here, fumes released in this reaction. When we drop magnesium here, that bubbles are formed vigorously in the liquid and that fumes are reaching the top of the test tube. When I brought a burning mastic, near the gases, what I noticed, it is changed into the blue color. So if a burning mastic changes its color into blue, that is indicating simply the liberated gas is hydrogen gas. Sometimes maybe it is put off by giving you sound, right? So here to identify the type of gas, I am depending on the color of the flame. So that turned into blue in color. So in this, what I noticed, gas is liberated. So that I made observation here. So in the activity 1, I observed heat liberated and nature changed. In the second activity, I noticed precipitate is formed. In the third activity, I noticed gas liberated. So what you observed finally changes. What you observed finally changes. So here, changes observed, right? They are physically or chemically. That you need to realize. If you observe physically, and that may be reversible, right? Sometimes may be reversible without change in the composition. Are you following me? Or any confusion? Here, changes if you observe only by its color, shape, or size, without change in the composition. Sometimes maybe they are temporary or maybe they are permanent. So that type of changes, we can call them as physical changes, right? If the changes irreversible, right? Irreversible, and composition also changed. Its chemical composition also changed. Then that type of changes here called permanent changes, and they are given as here chemical changes. So during the chemical reaction or the chemical change, what we are going to notice, that we are observing, and we are moving to another topic from the observations you made from these 3 activities. Are you clear about these 3 activities? Go to quick reaction, please. Everyone, are you clear about that activities? Right. So here now we'll go for another topic here. That is simply chemical reaction. So what is actually chemical reaction here? In the 3 activities, completely I observed changes in the physical appearance and also in different properties, because I noticed different substances produced, not the same substance changed into another form. Different substances produced. So in any combination or combination of any substance giving you a new substance with completely different characteristic properties with the original substance. If you compare that with the original substance, completely different characteristic properties observed, right? Then that change is considered to be a reaction here. So how do you define? Simply, it is a process. What, sir, why you are saying process? Because I am combining them. Sometimes maybe that combination takes place naturally in the nature. So that type of reactions, natural reactions. What, for example, photosynthetic process in the plants, right? Combining of gases, right? So that naturally taking place. So whatever it may be, the process is going on. What purpose? to produce a new substance, right? So the process of producing new substances or the process of new substances are formed by the combination of different materials completely with new properties. That only we are calling as reaction. So reaction is nothing, it is actually a change called chemical change. So chemical changes are considered to be chemical reactions. Chemical changes are considered to be chemical reactions. Are you clear about this? Any confusion? Are there any confusion? Reaction is what? Simply producing the new substances by the combination of different substances, right? So their characteristics are completely unlike to the original substances, right? So here I'm giving you example for the chemical reaction. Simple. We are burning many materials. So burning of any material, right? Burning of any material called a chemical reaction, because while you burn, what the original substances are there, they remains as same after the change. No, it gives you ash. While it is burning, it gives you heat energy and also releases some gases. So that's why this is considered to be a chemical reaction. Are you clear why I am calling this as chemical reaction? Burning of carbon or burning of paper, burning of wood, burning of fuels, for example, LPG gas, right? So everything. Sir, there is no ash remained. I am not observed because it is a gas. It will give you less wastages and it will give you heat and light releasing the gas, right? So burning of LPG also example for chemical reaction. So here that reaction we have here as carbon is combining with the oxygen and giving you carbon dioxide along with heat and light energy and remains as wastage hash, right? So this is example for the chemical reaction. Here what the original substances we consider to combine them, or maybe naturally the substances which undergo change itself, right? So here carbon and oxygen are there, they are changed as carbon dioxide here. So which undergo change or the original substances before the change are called as here, original substances are called as here reactants, right? Then after the change, what are remained? They are called as here products, right? Here we have byproducts also. What they are? Heat and light along with the carbon dioxide, heat and light. So here reactants there, products there. In a chemical reaction, we introduce two different quantities. What they are? Reactants, products. What are reactants? That substances which undergo change, they are called as here reactants. What are products? After the change, the substances remained, right? As a result, you are getting a new substance. That new substance is called a product. Are you clear? How I defined reactants, products? How do you identify it? Before the change, which we have, they are called as here reactants. After the change, what we have, they are called as products, right? So this is. Then we'll go for another here. We got about changes. We got knowledge about changes. That changes are considered here chemical reactions, and we represented that chemical reactions, right? Here now I am changing that chemical reaction into a equation form, right? So before going that, I need to observe the changes, right, during the chemical reactions. What happened? Many changes observed in the activity 1, 2, 3. So what do we observe during the chemical reaction, right? So in the chemical reaction, only rearrangement of elements takes place, right? Rearrangement of elements takes place, right? But no new element produced in the chemical reaction, right? no new element produced in the reaction. Then that characteristic properties are changed in the reaction. Previously, original substance, what the characteristic properties available, they cannot remain with the same characteristic property after change. That we noticed. Right? For example, please mute yourself. Right. Don't unmute. If you have any doubt, just raise your hand first. Before unmute, raise your hand. Okay. So in the first activity, I added calcium oxide. Right? It is solid form before change. It converted into liquid form. Okay. Sir, only physically changed. Okay. Then water has any nature? No nature. Calcium oxide in its solid form has any nature? No nature. But togetherly they produced a liquid. Right? It is homogeneous mixture. Right? Then that nature adopted by the both is given as basic blue color. Litmus paper changed into red, litmus changed into blue color. So that characteristic property changed completely, but no new element produced, right? Combined rearrangement of elements taking place, that I am explaining in the first point. Then here, no new element is produced in the chemical reactions. In any element, if we are able to produce new elements, no need to study the nature of the elements, that how they are available in the soil. We can produce many elements by the combinations. We are unable, actually you are unable to produce any new substance. Just you are able to change the combination. That is only we are considering as new substance, right? Here it is. Then in the chemical reactions, we may observe many changes, right? That are here simply called as characteristic properties. What they are characteristics? What the changes you notice, they are only we are giving as characteristic properties or characteristics of the chemical reaction. What they are here? New substances produced, right? What they are? New substances produced. For example, in a reaction of zinc and hydrochloric acid, you got a gas. It is a new product, right? So at least you will get one new substance, right? Or more than one substance also possible sometimes, right? Then here you may observe heat energy changes, heat liberated. In the activity one, the content becomes warm in the beaker. So that I noticed here, the ice change, right? Sometimes that may be absorbed heat energy also. To take the reaction, you may provide heat energy. So that also we can observe, maybe absorbs heat energy, right? Then you may notice undissolved material remains at the bottom of the liquids after the change. That we call as precipitate. That reaction called as precipitative reaction, right? Activity 2, the reaction between the sodium sulfate and barium chloride is producing the precipitate. So that reaction we can give it as example for the precipitative reaction, right? In the third one, I noticed gas liberated, evolved, right? So evolving, releasing of gas by the combination of two substances. Originally gas is not taken, but after the change, gas is produced in that. So that we can call it as evolved or liberated, right? Then we may change, observe change in the color of the substances, right? So like this we can observe. Then physical state also changes. Solid converted into liquid, or liquid converted into gas, or liquids may be converted into solids. Anything we may observe. So physical state also changes. Are you clear about these changes? What we noticed during the chemical reaction? How I have written the characteristics of chemical reaction? Are you clear? Yes, right. So I noticed the changes that only I am given as characteristics from the activities. Not only the 3 activities, many activities are there to observe. By observing them, be generalized like this, characteristics of the chemical reactions, right? Then here we are moving to another topic, that is here equation. What is actually equation? It is nothing but a chemical reaction, right? Chemical reaction, for example, one I am given, that is what burning of coal in the presence of oxygen. Actually, I am not considering the oxygen also in the air. Without air, you are unable to burn. Based on that, I am given oxygen because it is combining with only oxygen. So oxidation reaction is there. So carbon burned, right, in the presence of air, that from the air it is utilizing to combine only oxygen. That's why oxygen we are using. So that always saying carbon is reacting with the oxygen and producing the gas and liberating something heat energy remains as ash. So it is taking a time, waste of time, waste of energy. So I need to represent that reaction in a simple manner, right? So that is considered to be equation here, representing the reaction in simple terms, right? Short form. I am giving, right, expressing the reaction. So what that here it is called as chemical equation. So how can I write that chemical equation? Instead of writing the calcium, right, or carbon, I can use symbol, right? As you learned in the 9th class elements, right? Suppose calcium is there, what we can write? Ca. Water is there, what we can write the composition or molecular formula? H2. So that I am using here. Using the symbols and formulas, I am going to represent the chemical equations. I am representing the chemical equations, right? Reactions represented in the form of equation. That is here simply representing process of reaction by using symbols and formulas called chemical equation, right? So here, what is a chemical equation? Is a shorthand notation or representing the reaction with the symbols and formulas, right? So this is called a chemical equation. Then here in the chemical equations, we are using arrow symbol. Arrow always directed towards the change, right? Directed towards the change. Arrow direction always we are directing towards the change. Okay, so these are the important things. Then left side to the arrow, we are writing the substances which undergo change. The substances which undergo change called reactants. After the change, what we get or what the substances remains after the change, they are called as products. So left side to the arrow, I am writing reactants. Right side to the arrow, I am writing the products. Direction of arrow always towards the products. Always towards the products. So examples for writing chemical equations. For example, chemical reaction we consider. What is burning of carbon in the presence of oxygen? So always writing burning of carbon or coal in the presence of oxygen leads to produce ash and giving you heat energy, light energy, etc. things. It is difficult for me, right? So to avoid that, what I am doing here, I am writing simply using the words. Carbon is combining with the oxygen and giving you carbon dioxide. So I used words to represent the reaction. So this type of representation is called word equation here. What I can call this representation of reaction by using the words, that is called here word equation. That word equation can be converted into symbolic representation. So carbon is represented by C. Oxygen is represented by O2, gas, molecular form. Then it is together giving you carbon dioxide, CO2 we can write, right? So this representation using the symbols and formulas called as equation, chemical equation, right? So is it clear? Is it clear? Word equation is there, chemical equation is there, right? Don't call word equation as chemical equation because we not used any symbol or formula. No symbols, formulas taken in them. Is it clear? Right? So you are clear about this. I got knowledge about chemical equation. What is chemical equation? Represent the reaction, right? Using the symbols and formulas, right? In this, we are separating the reactants of products. What we written left side, what we written left side of arrow, they are here reactants, right? So here maybe more than one reactant is there. You can use plus symbol to separate them. Why we are using the plus symbol? Plus is used to separate substances which are participating in the reaction called reactants. To separate reactants, we can use plus symbol, right? Here, right side also we can use plus symbol, right? If more than one substance produced, right? That is called product. More than one product is produced, that can be added or represented using plus symbol here. Clear? Why we are using plus symbol? Are you clear why I am using plus symbol here in the equation? Plus is used to separate. Plus is used to separate the reactants or the products. Why I am using a arrow? Can anybody answer me? Why I used arrow? Anyone? Sricharan? Why we use arrow here? Importance of arrow?
The new product is formed in the reaction.
So, to indicate the change, right? To indicate change and its direction, right? To indicate the change and its direction, also to separate what reactants and products. Is it clear? Everyone got an idea about the equation? Are there any doubts in the chemical equation? If there is any doubt, just ask me here only. After this, we'll go for new topic. After this, we are going for new topic. That is here types of chemical equations. Types of chemical equations. Any doubts up to what we discussed now? Nothing? So join immediately using the same link in another meeting. Immediately join. We will discuss types of chemical equations. Harshit, join by using the same link. Okay.